Welcome to Science Hub. Today we're delving into the fascinating world of geology, where the seemingly stable surface of the Earth can sometimes surprise us with unexpected seismic activity. But what exactly triggers these shallow earthquakes, particularly when human activities are involved? Recent studies reveal that many human-induced earthquakes occur along ancient, seemingly dormant faults that haven't budged in millions of years. Over time, the surfaces where these rock layers meet begin to heal, gradually strengthening. This strengthening creates additional resistance, and when this resistance is finally overcome, it can result in a sudden slip along the fault, triggering an earthquake. This can happen even in areas that geological models classify as stable. These faults, despite being inactive for long periods, can be destabilized by human activities such as drilling, extraction, and fluid injection. Such activities can lead to earthquakes in regions that haven't experienced seismic activity in a long time. Often these shallow earthquakes occur at depths of just a few kilometers, making their ground shaking more noticeable and potentially more damaging to infrastructure and communities that aren't prepared for such events. Research indicates that regions without a history of seismic activity are particularly vulnerable to human-induced earthquakes. The infrastructure in these areas is typically not designed to withstand significant tremors, posing a risk to both buildings and people. Studies, particularly from Utrecht University, show that these earthquakes are often isolated incidents. Once the accumulated stress is released, the fault settles into a new, more stable state, suggesting that the area becomes safer after the initial event. Furthermore, as the fault strengthens during movement, the broken sections can slide over each other more easily, acting as natural barriers against larger earthquakes. This reduces the overall risk as the likelihood of more powerful quakes decreases after the fault slips. The research highlights the need for caution when using the Earth's subsurface for activities like geothermal energy extraction and carbon storage. Even in geologically stable areas, earthquakes can occur under certain conditions, albeit typically just once per fault. Researchers are working to improve predictions of human-induced seismic risks by developing new computer models that help understand fault healing and what triggers their acceleration or deceleration. In conclusion, recent findings show that faults considered stable can indeed be susceptible to shallow human-induced earthquakes. By understanding how these faults behave and the healing processes they undergo, we can mitigate seismic risks associated with subsurface land use in sustainable ways. With advanced computational models, predicting these single-event earthquakes can be improved, enhancing the safety of communities and infrastructure in the future. Don't forget to subscribe for more intriguing science content.